Alright, I'm going to do a video for this worksheet if you need a little extra help. So what we're moving into now is solving trig equations. So there's a lot of information here on this worksheet that I'm going to run through. So trig equations have an infinite number of answers most of the time because everything on the unit circle repeats. So for example, if we're looking for where sine of theta equals 0, that happens right here at 0, but then it also equals 0 at pi, and then at 2 pi, and 3 pi, and 4 pi, and 5 pi, and so on, and that goes on forever. So whenever we solve trig equations, we usually restrict our results to a given part of the unit circle so that our answers don't go on forever. And this is what your calculator does. So if you type in sine inverse of 45, it's going to give you a single answer instead of giving you 15 different answers or 1,000 million gazillion answers. So what the calculator is doing is it's using principal values. Principal values for sine and tangent are going to be negative 90 degrees to 90 degrees, or in radians, that's negative pi over 2 to pi over 2. Negative pi over 2 is here, it's the same as 3 pi over 2, up to pi over 2. So this is the first and fourth quadrant that you're looking at. But anything in the fourth quadrant, you're going to give those angles as negative angles. So, for example, if we get an answer right here at 7 pi over 4, we would not use 7 pi over 4. We would say negative pi over 4, which would be equivalent. For cosine, you're going to look from 0 to 180 degrees or 0 to pi, which is the first and second quadrants. So if the question asks you to give principal values, you will never give an answer from the third quadrant. And depending on whether you're looking at sine or cosine, you'll look at either first and fourth or first and second. So some examples that we're going to see here. We're going to do really simple ones here. We're going to solve the equation cosine of theta equals negative 3 pi over 2 for principal values. So what we're doing is we're looking at the unit circle to see where cosine equals negative 3 pi over 2. So we're looking at cosine, which is our x coordinate. And so we're just going around the circle to see where we see negative square root of 3 over 2. I think I'm saying that backwards. So negative square root of 3 over 2 is right here at 5 pi over 6. It is also at 7 pi over 6. But since this said principal values right here, we are only looking from 0 to pi, since this is cosine. So 5 pi over 6 would be our only answer. So that's what we would give here. For our second example, we've got sine equals negative 1/2 for principal values. So we're looking at the y-coordinate for sine, and we're going around. Right here we see, oh no, right there, right here we see our that we have negative 1/2, which is 7 pi over 6. We also see it show up over here at 11 pi over 6. However, neither one of those are between negative 2 pi and negative pi over 2 and pi over 2. So for principal values, we're looking at first and fourth quadrant, which would be this 11 pi over 6 here, but we want to give that as a negative angle. So instead of saying that it is 11 pi over 6, we can just start from 0 and go backwards pi over 6, and that would give us the negative pi over 6 that you see we have here. So that would be the answer that we would give if we're doing principal values. So I'm going to do a couple of these, and then I'll also post the answer key so that you can see this. So the first ones ask us to solve and give answers in radians. So if we just look at sine of theta equals 1/2, principal values for sine are first and fourth quadrant. So we're looking in the first and fourth quadrant, and we're looking for where our y-coordinate is 1/2. And that happens right here, which is pi over 6. So for this, we would say that theta equals pi over 6. For cosine, we have first and second quadrant. So here for where cosine equals 1/2, we're looking at the x-coordinate, that's cosine, and we can see right here, cosine is 1/2 here. So that would be pi over 3. So our theta would equal pi over 3. for that one. Now, some of these are going to be a little bit more difficult. For example, like number 4 here, we've got tangent equals 1. Tangent is not on our unit circle. So since tangent is not on our unit circle, we're going to have to think about this a little bit more. Tangent, remember, is sine theta over cosine theta. And so in order for this to equal 1, sine and cosine have to be the same thing. So if we look at our unit circle here, there are a couple places where sine and cosine are equal to each other. It happens right here at pi over 4, because we have square root of 2 over 2 and square root of 2 over 2. It also happens down here at 5 pi over 4, where both of our values are negative. However, principal values for tangent are going to be from negative pi over 2 to positive pi over 2. So we're going to use this one here, pi over 4. Would be our answer for that. For number 5, we've got sine of theta equals negative 1. So we are looking for where our y-coordinate equals negative 1. So when we look around the circle here, right here, we see our y-coordinate is negative 1. However, that is at 3 pi over 2. For our principal values for radians, we're only looking from negative pi over 2 to positive pi over 2. So negative pi over 2 is right here. So instead of giving 3 pi over 2, we want to say that theta equals negative pi over 2. For number 6, we've got tangent again. So we're looking for sine of theta over cosine of theta has to equal 0. And so since that's a whole number, we can put it over 1. So we're looking for where sine is 0 and cosine is 1. So that happens right here. Our sine, our y-coordinate is 0. Our cosine is 1. And that is at 0 radians. So we would say theta equals 0, which is between negative pi over 2 and pi over 2. It would also equal 0 here at pi, but tangent principal values are only negative pi over 2 to positive pi over 2, so we don't look over here on this side of the graph. And we'll skip a few of these and come down here and look at some of our others. Let's look at, let's see, what's a good one to do? Let's do number 9. Sine of theta equals negative 1/2. So for sine of theta equal to negative 1/2, we're looking for the y-coordinate equals negative 1/2. We're only looking in first and fourth quadrant here. So we can see here, right here, at 11 pi over 6, we have a sine that is negative 1/2. However, principal values are from negative pi over 2 to positive pi over 2. So instead of calling this 11 pi over 6, we're going to call it negative pi over 6. So theta is going to equal negative pi over 6. Actually, this says degrees, so let's go back and fix that. Instead of negative pi over 6, we're going to have negative 30 degrees, because we'll be looking at the degree there instead of the radians. One that's really tricky is number 14. You've got tangent equals square root of 3. So that tells me sine of theta over cosine of theta is going to equal the square root of 3, or you could even think square root of 3 over 1. But there's nowhere on the unit circle that sine equals square root of 3. So what we're going to have to do here is we're going to have to test some points to see what works. So I know for tangent, I'm looking first and fourth quadrant, and I know tangent is sine over cosine. So I know it's not going to be at 0. So right here at 0, tangent would be 0 over 1, which is just 0. At pi over 6, I would have 1/2 divided by square root of 3 over 2. And dividing fractions is easy as pie. We're going to flip the second and multiply. 2's right here can cancel, so we'll get 1 over square root of 3. And if we rationalize that, we can multiply the top and bottom by square root of 3. So we'll get square root of 3 over 3. So this was tangent of pi over 6. We need this just to equal square root of 3. So this is not our answer. At pi over 4, we're going to get just 1 because we'll do square root of 2 over 2 divided by square root of 2 over 2, which is 1. So this is not our answer. But let's hope that pi over 3 is going to be our answer because we're running out of terms that have square root of 3's in them. So if I test that, tangent of pi over 3 is going to equal sine over cosine, so it would be square root of 3 over 2 divided by 1/2. And so dividing fractions is easy as pie. Flip the second and multiply. 2's can cancel. We get square root of 3 over 1, which is square root of 3. So tangent equals square root of 3 at theta equals pi over 3. And I keep forgetting that I'm supposed to be doing degrees instead of radians. So really I should, instead of calling that pi over 3, I should do 60 degrees here. So your answer for 14 would be 60 degrees. So I'm going to post the answer key for the rest of these. So please try it first and then look over the answer key and see how you do on that.